Hello everyone, welcome to Data Science Shishya, a data science learning platform for students. In today's session, we are going to discuss about Numpy Library. So I have decided to teach you about libraries before going digging deep into data science concepts because we need to be familiar with all the data science libraries before getting into data science practicals. Because if we have strong basics in these libraries, we'll be able to easily understand the code when we are doing data science projects. So for today's session, I'll be discussing about Numpy library. It is a for okay. Numeric Python is an abbreviation for Numpy library. So now what is Numpy library? Numpy library is a Python library which is used for working with arrays and mathematical calculations related to matrices and linear algebra, and it was created in 2005 by Travis Oliphant. It is an open source project. Okay, now what are the advantages of NumPy library? Okay, now we can create powerful n-dimensional arrays with NumPy libraries. It is very easy to create arrays with the help of NumPy libraries, and NumPy will also give us numerical computing tools which are nothing but mathematical functions which are embedded into the library, which help us to do all the mathematical functions, mathematical calculations on linear algebra and arrays, etc. And performance-wise, NumPy is very good, and it is very easy to use because the syntax and the function names are very easy to remember. And since it is an open source library, it is free for us to download. And to learn, if you are interested to learn more about NumPy, please visit numpy.org, which is the official website for NumPy. Here, when you go through the NumPy, this is the official website for NumPy. When you go into the documentation in this website, this is a documentation page where you can see how to set up NumPy in your system, and how to code using NumPy, quick tutorials and all. Okay, now in my previous session, I've given you instructions on how to install, how to set up your system. So if you have already installed Anaconda in your systems, then automatically Jupyter also gets installed. Now how to open Jupyter Notebook is go to search bar and type Jupyter. There you can see how Jupyter Notebook has appeared. Click enter and Jupyter Notebook opens. Now the Jupyter Notebook opens in the in a browser. So this is the home page for Jupyter Notebook. If you want to start coding and open a new notebook for you, click on new and go to Python 3. Alright, when you click on this, an untitled page appears. So here, this is how it looks like. Okay, and if you have not installed Jupyter Notebook, don't worry, because I have told you I'll be explaining you about Google Colab also. Now go and search for Google Colab. Now click on this hyperlink, and it will lead you to the Google Colab welcome page. This is how it looks like. And one thing you have to make sure is for you to save your notebooks in your drive, you need to sign in with your Google account. And when you click on files, you can open your new notebook, and when you have completed your notebook, it will automatically get saved in your Google Drive. And if you want to download, here's the option. Alright, now when you open new notebook by clicking on this option, this untitled page appears in the Google Notebook, and this is how it looks like. Okay, now alright, now let's start with the practical sessions of NumPy. First, I'll show you. I'll execute two commands in Jupyter Notebook, and I'll execute two commands in Google Colab for you to understand, and then I'll continue with Jupyter Notebook. Now, how to install NumPy library into your Anaconda is simple. There are many ways. One way is you can use Anaconda prompt. Anaconda prompt. This is the most suggested way actually. When Anaconda prompt opens up, here just give pip install NumPy. When you click enter, it will start installing. Since I have already installed, I'm not executing this command again. Alright, there is also another way you can do it directly in Jupyter Notebook. Here, this block, enter pip install numpy and click enter. In this way also it works. So I've already installed it. Now to execute each block, there is a important rule is that you have to press shift plus enter button to execute each command line. Okay, I'll show you. Now since I've already installed numpy. Alright, since I already installed numpy, I'm going to import numpy package. Now how to do this? Simple. Import numpy as np. Now why I've kept it as np? Why command? Why type the command import numpy as np? Np acts as a reference to numpy. It is like a nickname to numpy. Alright. So you can give any name. You can give ABC, anything. So np is a globally used. That's why I've given it as np. Import numpy as np. So when you execute this command, it imports the numpy package, and now the same thing can be done in Google Colab also. This I have Google Colab page. Now just enter import numpy as np plus shift enter here also. Shift plus enter to execute this command. Yeah, see this is running the command, and since already the numpy package is already installed, uh, we'll be able to access it directly. Okay. We need to have strong internet connection for it to work properly. Yeah, so it has imported the numpy package. Okay. Now since I've shown you with Google Colab, I'll be continuing my session with the Jupyter Notebook. Alright. Now import numpy as np. We have imported numpy package. Now I'm going to comment it. Import. Now hash is used for comment lines. Importing numpy package. Okay. Now we have imported numpy package. And now uh, do let us learn about some important functions in numpy package quickly. There are a lot of first function I'm going to show is creating an array. How to create arrays in numpy. Creating arrays. Right. Now first we'll be creating one-dimensional array. 1D array. Now take up a variable for a array and take up a variable that I'll take it as a equals to np dot array, and now array is the function, and np is it is reference to numpy, so it will take it as array function from the numpy package is being called here. So np dot array, and now open square brackets. In this you can declare your one-dimensional array 1, 2, 3. You can also give character where character a b and a character and also string like hello. Now to execute this, press shift plus enter, and after this if you want to see a array, alright, you can give it as a directly, or you can also go for print. See, if you are going to give it directly as a, if you are going to give directly as a, it will show it as array data type, and it will show you all this information. If you are going to directly print, it will only print the whatever the data is present in the array. This is how it works. And now we are going to create multi-dimensional arrays, right? Multi. Okay. Now I'll be taking B. as a variable for array. Same np dot array, same function, nothing changes. And here we are going to take a square brackets. Now, one thing to remember is whenever you are creating multi-dimensional arrays, always remember in this square bracket, in this square brackets, we need to also create another square bracket. All right. Now I'll be taking this 1, 2, 3, and come out of this one, and I'm going to take it as uh, 4, 5, 6. Okay, I'm going to execute this. Okay, now errors have come. We have to take square brackets inside of the array function because it will throw an error. Okay, so I'm going to execute p. Now this is how it comes. If I'm going to take it as print p, I'm going to print it to return the data present in this array. Okay. So print p. This. Now this is taken as 1, 2, 3, 4, 5, 6. That's taken as a matrix form. And now, how do we for example, for instance, let us we don't know about the array. It is already present in the data we have taken. Okay, how do we check the dimensions of the array? So there is an option. Just press p dot ndim. Ndim method. P dot ndim method can be used just to check the dimensions. So here we, since it is a b is a two-dimensional array, it has given us two dimensions. It is given as value as 2, and yeah. And the next one is if you want to create an array with multiple numbers, if suppose I want to create an array with 30 numbers, so I don't want to type those 30 numbers all the time. So how can I create 30 numbers in an array? Okay, now I'll again assign a variable, say np dot array. Now we are not going to use array function here. We are going to use the arrange function, arrange function, and create a one-dimensional array with 30 numbers. Now this is how it gets created. Now you can see from 0 to 29. In Python, always remember index starts with 0. Alright, index starts with 0. In R, index starts with 1. In R programming language, index starts with 1. And in Python, index starts with 0. Okay, now what if I want to create it, what if I want to shape it, or what if I want to shape it into 5 rows and 6 columns? Okay, now what if I want to shape this array into 5 rows into 5 rows and 6 columns? Now just here again we will be using dot reshape of dot refresh, open the parenthesis, and again open double parenthesis, and give the number 5 rows comma 6 columns. Alright, executed. Yeah, this is how you can see a matrix, an array is formed with 5 rows and 6 columns. Let us check the dimensions of this array, multi-dimensional array. 6 c dot n dimensions. Alright. It's given us 2 dimensions because it is also a 2-dimensional array. Now, what if you want to give a gap between each number? What if I want to uh, print uh, print a number with a gap? Alright, if suppose I want to print it like 10, 20, 30 with a difference of 10 between each number, there is also an option for that. Now, I will be taking t as a variable now. np dot will be using arrange function, arrange of. Now first I'm going to declare the starting number. starting number as, let's take it as 10. 10. Ending number is 300. Okay, alright. Now this is a range, that mean range I'm going to give within 10 to 300, and the difference I want to allocate is 10. Okay, and now I want to again reshape it into, let's say, 4 comma 5. Right. Right. Now whenever you are going to, you can't blindly assign reshape values here, because you always remember, whenever you are going to assign reshape it, we have to make sure that it fits. Alright, we have to make sure that it fits. Okay, now let's try it again without reshape, and because all these numbers we have created must fit into 4 rows and 5 columns. Okay, so you cannot reshape array of size 29 into shape 4 comma 5. Okay, now I will take it to D. Alright, now how many numbers, for us to assign reshape, we need to know how many elements are present in it. Now let's say there are 29. There are 29. So okay, I'll make it as 0 here, so that I can get 30. Now I'll be assigning the same reshape for 5 comma 6. Since 5 6 are 30, alright. Since 5 6 are 30, I'll get 5 rows and 5 columns, 6 columns, or 6 rows or 5 columns, and your wish. 5 comma 6. That is how it looks like. See, 0, 10, 20, 30, 40, 50. Now this is how we can make use of a range function, and there is also a function for stacking. For example, okay, I'll quickly create. I'll make use of the same C and D arrays for making the stacking, for creating stacking. Okay, let's start with stacking. Now what happens in stacking is, there are two functions. One is h stack and v stack. H stack stands for horizontal stacking, and v stack stands for vertical stacking. Now in h stack, I'll show you how it works. Now quickly, np dot h stack. You can also assign it a variable, like so let's say h for h stack. Okay, rest np dot h stack function. I'm going to call it stack function, and double parenthesis, and I'm going to call it c comma d. All right. Let's execute it. Okay. Now, if you noticed how stacking up has occurred, now, when you see both C and D, let's see how stacking has occurred, how it has combined two arrays. All right. Now check it. Since we have taken C as first and D as second. So we have started with C 0, 1, 2, 3, 4, 5, and it has combined the next row of the D. I mean it has combined first row of C and first row of D into one line. Here as you can see, first row of C and the first row of D into one line. This is how it occurs horizontally, because it's a horizontally combining. This is a H stack, and when we are doing this vertical stack, I'll show you how it works. V is equal to np dot v stack function, v stack of parentheses and c comma d. Okay. I'm gonna call v. See, this is how it works. Till here the rows are combined, and here it will combine columns. It will combine columns directly. Here you will not be seeing one row, first row, second row combining. We'll combine the two arrays directly. Two arrays directly. Here you can see it will not be combined directly. It will first combine this array, take all these values and combine D array. Here you can see it has started with 0 to 30, 0 to 29 and again 0 to 290. This is how it vertical stack works. And now the next one is matrix multiplication. Here you can see it is also type of matrix. So I'll show you how to multiply these two matrices. H and V. Okay. Now let's say M. I'll take M for multiplication, and the function we are going to use is matmul. Np dot matmul mul of, and here we don't need double parentheses. You can directly take it as H comma V, right? Okay, since the dimensions don't match, that's why it's not able to multiply. Okay, all that fine. So for matrix multiplication, we need the dimensions to match. The dimensions don't match, so it's not multiplying. Okay, I'll take C and D. C and D. Okay. Okay, I think it's throwing an error that input operand 1 has a mismatch, needs 4 dimensions, 0, which is okay, something else. Some errors occur. Okay, let me create quickly two arrays. Okay, quickly, let's say a1 equals to np dot array of 1 comma 2 and 2 comma 3. Got I'll copy quickly. Paste it in. A2. Okay. A2. Yeah, let the values be same. Okay. Now np dot match of a1 comma a2. Okay. Now this multiplication has occurred here for this matrix. Okay. Now, yeah. So sometimes we might be able to create a matrix entirely with zeros or a matrix entirely with ones. Sometimes it happens. So we are going to create matrices with only zeros and only ones. Okay. Now creating matrices with zeros and ones. Now the functions we are going to use is, okay, now let me quickly create a zero matrix. I'll take the z is equal to np dot zeros. Okay, now I'll double parenthesis and I'll mention it as a 4 by 4 matrix. I'll create a 4 by 4 matrix with 4 rows and 4 columns, and let's see how it looks. Oh, sorry. This is how it looks at the zeros. And if you want to create a matrix with ones, O equals to dot zeros. Sorry, ones here. Np dot ones. If you want to create ones, we have to take it as np dot ones. Double parentheses and 4 by 4. See, this is how it looks. And okay, sometimes, okay, we have multiple dimensions here. Okay, I'll quickly check the dimensions of this matrix without endgame. Okay. Okay. Now we have two-dimensional data. Sometimes when we are doing a data science project, we will be asked or will be required to convert an n-dimensional array into single dimension. Okay. Now how to do this is we'll be using Ravel function. Okay, a Ravel function is used to create any n-dimensional array into single dimension. Okay, now I'll take it R equals to, I'll create the once matrix into one dimension. So here we have two dimensions. Now I'll make it into one dimension. Now np dot Ravel equals to, sorry, np dot Ravel of oh. Okay. Now you can see how many dimensions it has. R dot nd. Let's see, it's just converted into a single dimension. And okay, if you want to quickly take up a random number, how to we take up a random number quickly? Okay, np is equal to take as random, rand equals to np dot random dot random. This is how you can create a random number using NumPy. And always remember, when we are using np dot random dot random, the range of the random number generated will be from 0 to 1. Okay, I'll also show you how the range works. Okay, now execute ran. Now yeah, this is a random number generated between 0 to 1. Now to check the dimension, to check the range, okay, there is a function to check the range. There is a function to check the range. Okay, to check the highest and the lowest values in the observations. We'll be using instead of max and min, we can also use floor and ceil. Okay, now np dot floor, floor means the highest value. Okay, input dot floor of np dot random dot random. Okay, now it's okay. Yeah, floor means sorry, 4 is the minimum value. Sorry, my bad. 4 is the minimum value, and if you want to check the maximum value, np dot ceil, ceil, sorry, ceil, np dot random dot random. Okay. Now, okay, it's come. So the zero range is between 0.0 to 1.0. Now, what if you want to create a random number? Okay, a random number between 100 to 200. I need if I need a random number between 100 to 200, what should I do? So we can use randint function. Okay. Now simply take np dot random dot randint. I'm gonna give the range 100 to 200. Okay, that's good. Now it's taken 133 as a random number. And what if I want to create an array of random numbers? Okay, what if I want to create an array of random numbers? Okay, now it's the same function in randint np dot random dot randint of. Now I'm going to take out the starting value as 100, ending value as 200, and the difference between each. And how many random numbers I need? I need 20 random numbers from the range of 100 to 200. Okay, I'll execute this. See, we have got 20 random numbers randomly picked. Alright. Okay, there are also functions to deal with sine and cosine, trigonometric function. Alright, I'll explain you how trigonometric functions work. Okay. I'll show you how sine, cos, and tan. Okay. Now, okay, let me quickly assign a variable to this. I'll take A. equals, okay, a equals, executed. Okay, now I want these values to be converted into trigonometric values of sine, cosine, and tan. Okay, before that, we need to convert these values into radians. Okay, a radian values is equal to, so we have to take up this formula, a into a multiplied by np dot pi, pi value np dot pi divided by 180. So this is used to convert those degree values into radians values for us to perform trigonometric functions. Yeah, I've converted it. Now quickly, let me do the sine operation. Np dot sine of x x radians. Okay, sorry, a rad. So these are sine values, convert to sine values. Now if you want to do cosine, np dot cos of a rad. If you want to work with tan and put on tan, want to get tangent values and put on tan of a rad. There. Okay, now we have checked it. We have taken, we done trigonometric functions also, and now, okay, now if you want to check null values in the data using numpy, null values in an array using numpy, quickly do np dot is nan method is nan of a. So since a doesn't have any, it gives false values. So if you want to know with how many null values are present in my array, okay, dot just directly dot sum function, okay, dot sum function, and it'll give you the value as 0. Okay, to check the null values. And quickly, if you want to have the square root, if you want to quickly check the square root, sqrt a sq, okay, for the square root of a values, okay, np dot sqrt of a. Okay, these are square root values. If you want to check cube root also, there is the functions, okay, a cq, okay, a cq, np dot cbrt, I guess, np dot cbrt of a. Now you will get cube root values for a, sorry, a cq. So guys, these are the basic functions. You need to be familiar with NumPy for beginners. This is the NumPy for beginners, obviously. These are all the functions you need to be familiar. It's easy to remember all these functions. Once you just practice it one time, you'll be able to easily remember it. Okay. Now to execute a line, press Shift plus Enter. Alright. Now if you want to save the file, okay, already there is a download as IP. There's, yeah, download as notebook. It will download this file, and if you want to rename it, there is a rename option. Okay, uh, and other option is if you want to add a cell in between, just click on this option to add a cell, and to move this cell to up, there is this button, upward arrows, downward arrows. Okay, can have upward arrows. Now if you want to give a heading like notebooks, okay, I'm going to give a heading. Okay, this is NumPy, right? I've given it a heading. So this is it, guys. If you are interested, there is also another library. If you want to learn, it goes with the name Skippy, CIPY. So this is mostly it deals with scientific and statistical calculations. Okay, this library Skippy deals with statistical calculations. When I'm doing data science parts, I'll use the Skippy function. And this is it for NumPy, guys. Thank you very much. And tomorrow, tomorrow in this next video, I'll be discussing about data visualization through Matplotlib. All right, data visualization through Matplotlib and Seaborn. Once again, please, if your friends are interested in data science, please share this channel. Thank you very much for your time. Please practice. Happy learning.